There we go.
Cool.
Business. I'll get that going.
Thank you. I'll get through this stuff really quick. So I've had this slide on the presentation in the past, and people ask why libvirt, and really beyond all of the cool things libvirt gives you, probably the biggest benefit to this audience is that it's a bridge to the greater open source virtualization tools, things like Virt Manager, Virt Viewer, Kimchi, OpenStack, list goes on. And really, the end to the means for us working on this thing is to make all these applications available on Xen, or with Xen. So we have a couple drivers in libvirt for Xen. We have this old XenD-based driver, which people really should not be using. We have a newish one, the libxl one. It's actually been around for quite some time. I think this was committed to the libvirt repo in April of 2011. The couple things I wanted to point out here, though, was that we recently bumped a minimum API, libxl API version to 4.4. And main reason for that was support migration v2 easily without a bunch of hacks in libvirt to support older Xen versions like 4.2 and 4.3 that aren't even maintained upstream anymore. And one other thing that's probably worth reiterating is that last point there is don't mix and match libvirt or libxl apps. libxl stateless, most of the state is in the various apps that use it. So if you're using one app and change some state there, it's not reflected in another. It's best just not to mix and match them. Okay, so on to what's new, things we've done this year. Yes, Conrad. So, yes, would love to remove that thing from libvirt. Ask about that maybe 6-8 months ago when taking care of a bug that Ian Campbell found, actually. And folks were hesitant to remove it. It's probably worth bringing that up again to the libvirt community. I'd really like to get that out of there. There's a couple components, though, that may be useful in there. There's a component that does hypervisor I/O controls, and there's also a Xen store component in there. And those could be useful. I mean, I've often thought I should, a cool little side project would be to make a new driver for Xen and libvirt that used the hypervisor I/O controls, Xen store, libxen control, and so on. Use those things directly and not bother with libxl. Then I'm not so dependent on things needing to be done in libxl before we can make them available in libvirt. So some items that we've worked on in the past year. This is a pretty cool one. Is native block device access to Ceph or a Ceph cluster using QDisk. So OpenStack Cinder, actually this is a common configuration. Cinder, a common configuration is to have a Ceph backend for Cinder. And so with this support, this has been in the QEMU driver in libvirt for quite some time. But with this in Xen, you can do things like attach a Cinder volume that's backed by Ceph to Xen PV and HVM guests running on Xen compute nodes. So that's pretty cool. And I've given some examples of both the libvirt domXML and the xl.cfg configuration. The libvirt one's a little more expressive. You might notice that auth is supported as well. xl.cfg, you have to just kind of encode all of this stuff in the target setting of your disks. We added support for minimal VIF quality of service. libvirt actually supports specifying average, peak, floor, and burst bandwidth limitations for both incoming and outgoing traffic. libxl only supports a rate and an interval on inbound or on outbound. So about the best we could do in libvirt is support the outbound average, but we got that implemented. The next feature there is actually a pretty cool one, I think, and it's support for assignment of SR IOV devices from a pool of them. libxl and libvirt have long supported assigning a specific virtual function from an SR IOV device to a VM, but there's some limitations to that, right? If you go to start the VM and that virtual function is in use or not available for whatever reason, you're not going to be able to start the VM. You're going to have to go and edit the config and find one that's available and put that in there and so on. What this does, and it also kind of applies on migration as well. If you migrate to another host, and if that exact same hardware, an exact same slot, an exact same PCI bus is not available, the migration will fail. What this does is allow you to take all of your SR IOV devices and assign them to a network pool in libvirt. And the only thing you have to do, as you can see here, is reference that pool by name, like this one is an example SR IOV pool. And what libvirt will do is find an available device out of that pool, assign it to the VM, bind, unbind the drivers, anything that's necessary, and it kind of eliminates these or alleviates these limitations that I talked about. So that's really a cool feature, actually. We managed to support UEFI for HVM guests using OVMF. Example of the configuration there in libvirt domXML. It's, you specify this stuff at the loader element within OS block. Some things that aren't supported that libvirt supports, that we're not yet supporting in Xen, is secure boot. There's actually another attribute here on the loader element called secure, which can be on or off, and also non-volatile memory for storing firmware variables. We don't have support for that in libxl either. If we could get those two items, it'd be easy to plumb that up in libvirt. pvUSB. This is one that one of my colleagues at SUSE, who's sadly no longer SUSE Chunyan, Louis had worked on, and she got this stuff implemented in libxl and then moved up the stack and implemented this in libvirt as well. Has the ability to create and destroy controllers and then attach host USB devices to those controllers. And you can use either bus device notation or vendor and product ID notation to identify those devices. These next two items actually were contributions from Joao Martins from Oracle, and he implemented these to provide better support for OpenStack Nova. Nova uses a lot of the libvirt statistics APIs to get memory, CPU, block, and VIF statistics, and that was lacking in the libxl driver, so he provided patches to implement that. It's really cool. And the other is peer-to-peer migration. And peer-to-peer, maybe the best way to show this is actually just by a picture. I don't know if you can see that okay. So the peer-to-peer one's here on the bottom. The upper diagram is kind of a standard libvirt migration where a client connects to both the source and destination libvirts and kind of orchestrates all the phases of migration. With peer-to-peer, a client just connects to a source libvirt and initiates the migration, and then the source and destination libvirts, they kind of orchestrate and handle all the various phases of that migration. And a nice benefit of the peer-to-peer approach is that, this thing could, once the migration is initiated, that client could die or lose connection or whatever, and the migration can still proceed. And I think that's one reason that Nova folks were interested in this, right? Nova could just start the migration and then query a job API to see the status of that. And if Nova crashed or whatever, life could still be good as far as the migration goes. Support for migration stream v2 is something we added. This was more of a bug fix than a new feature. libvirt had no way to tell either participant in migration what version of the stream it was dealing with. And as I mentioned earlier, it's one reason we killed off or bumped the minimum API requirement to 4.4, was to kind of take advantage of the ability to be able to notify or first detect what version of the stream was going to be produced on a producer, and then at a consumer of that stream, notify them of what version it was going to receive. One nice upshot of this work, actually, though, was I implemented migration cookie support in the libxl driver. The QEMU drivers had this for some time, and this is pretty cool. It allows cookies to be passed back and forth between the source and destination throughout the migration process. And there's several phases of migration in libvirt, I think 5 of them. And allows for things like sanity checking. So in the begin phase, we can pass a cookie over to the destination and say, here's the configuration of this VM. Is this something you can support? And the destination can say, well, not really. I don't have this much memory. I don't have these CPUs, or I don't have this bridge, or whatever it is. And that could be passed back to the source, and we could just abort the migration instead of proceeding with something that's doomed to fail. Capabilities reporting. This one is used by quite a few libvirt tools. They will query capabilities to know what's available here. What operations can I perform for any given VM type? What type of disk is the support? What type of buses, so on. So that was a quite important feature to have for tools such as virt manager and ovirt, and Kimchi even does an awful lot of capabilities probing. Improved XL to libvirt domXL conversions. This is actually a really nice feature because folks don't like to handcraft XML. So if you have some XL configuration, you can just run it through this virt domXML to and from native to go back and forth between the two. It makes it easy to switch between the two tool stacks, and it's actually a nice debugging aid. We can, if you're using libvirt and you're having some problem creating or managing a domain, you could convert that XML to xl.cfg, use XL directly, and determine, is my problem in libvirt or is it something in a Xen tool stack? Domain hooks is another cool feature in libvirt that we've been able to implement in the libxl driver. A colleague of mine at SUSE, Cedric Bostanot, actually implemented this. And hooks provide an opportunity for users to tweak the settings of the VM, or even configuration in the host prior to starting, stopping, or migrating a VM. So you could set up, some fancy storage device or some network aspect of your host just prior to libvirt, then invoking the operation. I have a link there to the hooks page on the libvirt website, which has more detail, but essentially what you do is take you implement a file called libxl for the libxl driver, whatever it is you want in there, drop it in this etc libvirt hooks directory, set it to executable, and then that would be executed when your VM starts or stops or is migrated or saved. Job statistics, this is another one that Joao had done. Again, in support of OpenStack, as I said, they'll do things like kick off a migration and then query a job API to get the status of the migration job. Conrad, one thing I did manage to do is remove a bunch of the old crappy support for XenD config formats in that old driver. There was support for XenD config formats clear back to Xen 3.0, and the code was just so ugly. And as I said, I think Ian Campbell has stumbled across some problem on ARM with like max vCPUs or something, and instead of more hacks in that driver to get around this problem, we decided, and the libvirt community was fine with that, of supporting just the very last XenD config format there was before the stuff was killed off. So it really cleaned up that old driver. But as I said, it'd be nice to just yank that from the Git repo entirely. Packaging, this is one that's, this item is really not Xen or not libvirt specific. It's not even Xen. I mean, I guess that's a downstream packaging thing. George had kind of mentioned it early on this morning about how folks want to use their QEMU and CBIOS and OVM and OVMF from their distro packages instead of the Xen in-tree equivalents. And most of the distros, including SUSE, have moved to this. So any of the configure options for Xen, the minus with minus system, QEMU, CBIOS, and so on, any of those that can be, more of those that can be added to Xen, please do. Trying to, QEMU has bugs like any software, and if you have to fix those bugs in the QEMU package and also in the QEMU provided by Xen, I mean, it's just error prone, and this is much nicer just to use your distro packages instead of the Xen built ones. Doug, you had a comment?
I'm just going to echo that, because I think I echoed that on the mailing list. And I mean, I'll throw out, find me a distro that uses the Xen provided tarballs for those things. It won't.
Well, CentOS because I'm lazy. But.
Okay, fine.
Yeah. And,
we'll go round and on the bay.
Hopefully.
CentOS, let's stop shipping them.
Yeah.
It'll save us so much more maintenance.
I think Fedora has moved to this now. Yeah, they have, because one thing you have to keep in mind, though, is providing the old QEMU DM. That you still need to provide in your Xen package, because if you have VMs laying around that use this thing and it's not there, you're dead in the water, right? So, but yeah, I mean, we were struggling with this back when we, provided both of these things. So you get tons of security bugs on the QEMU, and our package maintainer for that, fixing them there, and duplicate bugs for the one in Xen. It's just a maintenance nightmare.
Because they're slightly different, the distro shipped a slightly different version.
Right.
And they don't apply.
Yeah, it's not like, just take those patches and apply them to the others, often some backporting effort, and yeah, it's just much better to use the distro provided stuff if possible. I'm pretty much running out of time here, but I'll just talk quickly about some things that we're working on now. Joao's actually working on the top one. It's essentially supporting xl.cfg CPU ID equal setting. Another guy at Oracle, Bob, is have some patches on the list to support multiple serial devices. I have a patch to support Open vSwitch. The last one there is kind of an interesting one. Having some problems with the Xen PCI backend and or the PCI back driver in libvirt. And it's because libvirt uses these new ID and remove ID sysfs interfaces, which are really racy and quite buggy. So I have a patch on the list to use the newer driver override interface for binding and unbinding devices, much more deterministic. Some things that we no work has been done, I've been planning on, or would certainly like to see is better control for domain memory and CPU placement in NUMA machines. Supporting config like I have here, so that we can kind of control where these resources come from, which NUMA nodes, and also maybe exposing some vNUMA to virtual machines. pvSCSI, if this stuff can get in 4.8, we kind of already have some patches lined up for libvirt to implement that there. Block device quality of service would be nice. Yeah, some other things here. QED image format, I'm not sure how many people even in the KVM world are using that, but it's probably pretty simple to add that support in Xen and in the libvirt Xen driver. Some things that would be nice to have in libxl, you can read these as well as I can talk about them. The only one I may want to mention a few things on is the last one here. While working on the OpenStack or the Open vSwitch support and libvirt+libxl driver, come to find that it would really be nice if apps using the Xen tool stack could do some of the stuff themselves. So they create a ton or tap device, they connect that thing to a bridge, they set up port profiles on it, do all these things that the Xen tool stack can't do, and then just pass a descriptor down there and say, here you go, use this for my VIF. That'd be a really cool feature in libxl, actually. George?
Can network scripts not do something like that? Or?
So they could, but we have to have a way to then provide all this information in XL somehow. So it needs to be exposed in the structures, and then xl.cfg has to support this, and yeah, it's an option. But one nice thing about if this was available, I could use a lot of existing infrastructure in libvirt. So it's already there for the QEMU driver. This is pretty much how a lot of things are done on the QEMU side. So thanks for the folks who have contributed over the past year to the driver. It's been nice to have someone other than myself. And as usual, help's always wanted. If you're adding something cool to libxl, think about adding that to libvirt, because then it makes it available to all these apps that libvirt supports or written to libvirt. And yeah, with that, if there's any requests for some features in the driver or questions, happy to take those. Sure.
I want to ask about the large migration statistics. What detail we can get to more than the progress? We can get, for example, number of safety pages, the iteration, the multi-data transfer.
So devices, maybe it'd be, well, I can get with you. I'm out of time here. I could actually show you some of the stuff that those APIs produce. Anything else?
To what degree is, because libvirt is in a sense, it's not a hypervisor abstraction layer, it's a hypervisor communication library. So I know things like over, for instance, can't really use that at the moment because there's a whole bunch of stuff that's hard-coded that's focused on KVM. So to what degree is that true for other projects that use libvirt, and is anyone working on making those able to use?
Most apps actually do work pretty well without any tweaking. One thing I wanted to show here is just not enough time and a half-hour time slot is Kimchi. It's a web-based app that IBM has worked on, and this thing just works out of the box with Xen. I can bring it up, I can connect, and poof, I'll see my running VMs and so on. It dies off pretty quickly because it has some kind of brain-dead approach to querying capabilities of the hypervisor. It'll do things like, oh, let me define some XML, domain XML, and if that succeeds, then that must be fine. And so then it'll undefine a thing and continue on. And the logic in there, I was looking at the code, is things like, if some variable equal test, else equal KVM. It's like, come on, you could be a little bit smarter about how you develop this app, right? And so if folks have, considered multiple hypervisors when creating this app, things work pretty well out of the box. I mean, like I said, I could bring up Kimchi and poof, you'll see all your VMs, but the server just dies off quickly for doing brain dead things like I mentioned.